This is our statistics lesson, so I'm going to condense this lesson into just one, well, it's actually kind of a little mini unit, but I'm going to do it in just one lesson because it's super easy. Our learning target is I can answer very basic questions about studies and statistics. So this is more like common sense and just some terminology. And then we're going to do a few math problems where they actually give you the formula. So all you have to do is just plug it in and be able to hit enter in your calculator, and it's pretty much done. Okay. So here are 3 vocabulary words that you need to understand: population, sample, and parameter. Okay, so the population is an entire group that you want to draw conclusions about. So it's the part in B and it's in blue. And then we'll talk about a sample. So sample is the specific group that you will collect data from. So a sample is like a small portion of the population. And if you look at the picture, that's A. The last thing we're going to talk about is something called a parameter. That's a characteristic of a population. So the parameter is what you're looking for in the sample, and we're basing that on the entire population. Okay, so I want you to try this one. See if you can figure out what the population, the sample, and the parameter are for this example. You are interested in finding the height of sophomore girls at Surrey Early College. So try that in 1, 2, 3. All right. So your entire population is going to be the Surrey Early College. Alright, but you're definitely not going to sample everyone. You're just going to sample sophomore girls. And the parameter is the characteristic we're looking for, and we're looking at height of sophomore girls. So that's how you do these. Pretty easy, just some basic terminology. Okay, so there are 3 main sampling methods that we'll talk about in this class. If you ever take stats at the college level, you might see like some extra ones or just more specific, but this is what we focus on. So a survey. A survey collects info from a sample to learn about the entire population. So an example, mail, telephone, online, interviews, etc. And then you have experiments, which you've talked about a lot in science classes. So an experiment is a treatment. A treatment is assigned, and a control group is used for comparison. And then the last one is just an observational study. The sample is studied or measured as it is. So you don't try to do anything, you're just observing. Okay, so what I'm going to start to do is we're just going to look at some EOC problems, and we're going to see if we can answer them. So what I want you to do is I want you to pause the video, and I want you to try number 1, number 2, and number 3, and then we'll talk about them. So pause the video and try them in 1, 2, 3. Okay, so hopefully you had enough time. If not, you can pause the video again. So number 1, a student wants to determine the most liked professor at their college. Which type of study would be the most practical to obtain this information? So A, we didn't even talk about, so not simulation. An experiment doesn't really make sense. An observation, I mean, you could observe who likes who, but really, just a survey. So that's just basic common sense. All right, number 2. So you got to pay attention to some of the words. Mr. Beamer wants to survey 50 students to determine an elective to offer during the next school year. There are 335 students in the school. Which procedure could he use to select a sample using a systematic random sample? So when it says systematic, it means there has to be like a method to it. And when it says random, it has to be completely random. So A, obtain a list of all students. Start with the 8th student and select every 12th student until 50 students have been selected. That definitely has a system, and it is random. So we're going to put a little star. That could work. B, select the first 50 students who enter the school. That's not random because you're picking only the people who come to school early. C, choose the 5th student to come into the night's grill and choose every 3rd student until 50 have been selected. That is systematic. It's not random because you're only choosing people in the grill. D, place the students' names on a slip of paper and choose 50. So that is random, but it is not systematic. So the only one that's going to work is A. Okay. Number 3, a reporter wants to, know the percentage of voters in the state who support building a new highway. What is the reporter's population? So if you look at A, that's the number of people who live in the state. You don't want that to be your population, because if you think about it, people who live in the state are going to be infants, and they're not going to be voting until they're 18 years old. So not what we want to choose for the population. B, the people who are interviewed in the state, so that's not random. All voters over 25 years old in the state. The voting age is 21, so that doesn't make sense. And D is all eligible voters in the state. So you wanted to know the percentage of voters, so you definitely want the population to be all eligible voters. And then if you were going to take a sample, it would be out of those all eligible voters. But the population would be all of them. Okay, and then number 4, I'm going to let you pause the video and try this one in 1, 2, 3. Alright, so this one says, which method is most likely to produce a random sample of 5 students from a school club? So we're going to pick the most random one. A, selecting 5 club members who have brown hair. That's not random. You are profiling. Okay, B, selecting the 5 club members who have raised the most funds for the club. That's just, the most go-getters, not random. Selecting 5 club members from a hat containing the names of all members. That sounds pretty random. And D, selecting the 5 club members who arrive last to a club meeting. Not random. So C is the only one that's really random. Okay, so now we're going to look at statistics. And we're gonna talk about some different things. This right here is called the bell curve. And it is how, exams, EOCs, everything has been normed. So when you talk about a curve, not everybody gets the same amount of curve. If you're in the middle, you get more of a curve. If you score really high, you don't get as much of a curve. If you score really low, you don't get as much of a curve. Okay, so I just want you to take a minute and pause the video and read through this in 1, 2, 3. Okay, the only thing I need to add is right here, and this is just some formatting issues, should be this letter. This is mu. It is a Greek letter, and it just stands for the word mean. So that is a Greek letter. Mu stands for mean. Okay, so a normal distribution with mean and standard deviation has the following properties. About 68% of the data is within one standard deviation, so from here to here, 68% of your data should fall. About 95% of the data is within 2 standard deviations, so right there and there, and 99% of the data is going to be within 3 standard deviations. So right here is mu, that's your mean, and then if you go over here or over here, you move 1 standard deviation away from the mean. If you're here or here, you're 2 standard deviations, and if you're here or here, you're 3 standard deviations. So we will talk more about this if you take Math 4 with me, or if you take statistics with the college. You'll spend a lot more time. Ours is very basic, so let's just read the problem. A town has 685 households. The number of people per household is normally distributed with a mean of 3.67. So that's the average. And we have a standard deviation. So we're also missing another symbol. This is sigma. That's a Greek letter. Sigma stands for standard deviation. So our standard deviation is 0.34. Approximately how many households have between 2.99 and 4.01? So here is mu, and we're going to go up 1 standard deviation and down 1 standard deviation. So what I'm going to do is I'm going to add 3.67 and 0.34. All right, so 4.01 is 1 standard deviation above, and then I'm going to do 3.67 minus 0.34, and I get 3.33. So that's 1 standard deviation. 1 sigma. All right, so I got this number. So that's good. All right, but I still need to get to the 2.99. So I'm going to go down another standard deviation. So I'm going to do 3.33 minus 0.34, and that's when I get that 2.99. Okay, so notice what happens. See this 34% right here and here? So 34% of my data is between 1 standard deviation below the mean. 34% of my data is 1 standard deviation above the mean. Right here, I have 13.5. So 13.5% of my data falls right here. So I'm just using that chart, which they will give to you. You don't have to know it. Okay? Alright, so what I'm going to do is I'm going to add up these percentages. So 81.5% of households fall between 2.99 and 4.01. If you'll remember back in middle school or in elementary school, anytime we want to change a percentage to a decimal, you move the decimal place twice to the left. Anytime you say the word of in math, it means multiplication. So 81.5% of 685 just means change it to a decimal and multiply. So if I do 0.815 times 685, I get 558. So I would expect 588, goodness. I would expect 558 people to fall between 2.99 and 4.01. Alright, so let's look at this one. In a set of test scores that are normally distributed, a test score of 76 is 3 standard deviations below the mean. So right here is mu, that's my mean. 1, 2, 3. 3 below, I would find 76. A score of 88 is 1 standard deviation above the mean. And I'm trying to figure out what the mean is. So the first thing I'm going to do is I'm going to find the difference. So the difference, 88 minus 76 is 12. And notice that there are 4 sections, so these would each go up by 3. So 3 would be my standard deviation. If I went from 88 back down to the mean, 88 minus 3 is 85. So 85 would have had to been my mean. Alright, we're going to talk about margin of error. Anytime that they do statistics on the EOC, I have noticed that they have given you this formula. So as long as you know where to plug stuff in, you're good. I try to color code it. So we'll talk about this in Math 4 more, and we'll talk about it in statistics if you take it at the college level. The margin of error is the maximum likely difference between the estimate and the actual value of error. So remember, we are sampling just a part of the population, so you're not going to have the perfect number, so your margin of error allows for that. So the formula for margin of error is 2 times S, which is your standard deviation, divided by the square root of N, and N is your sample size. Okay, so 2,580 teenagers were surveyed about being left-handed. The standard deviation was 2.85, that's my S. Okay, this is my sample size, that's N, and I'm going to find the margin of error. So it's 2 times S was 2.85 divided by the square root of N, 2,580. I'm going to put that in my calculator, and I get approximately 11.1122. And then, or if they ever want to change it to a percentage, remember you just move your decimal back 2 places. But both of these are the same. So we're going to try this one. A high school randomly selected 75 of the 200 seniors at the school to take a sample college entrance exam. So 75 is your sample size again. The mean grade point average of the seniors selected was 2.85, and their standard deviation was 0.04. That's your S. We're going to select all of the statements that are true. So this is what you're going to see on the EOC. Sometimes you're going to see select all, which means there could be more than one. So note, margin of error where S is the standard deviation and N is the sample size. So they give you that formula. They tell you that S is standard deviation. They tell you that N is the sample size. You just have to know where to plug it in. So I want you to read through the answer choices and see if you can pick out which ones are true. Try that in 1, 2, 3. Okay, so the two that are true are B and C. So for B, I'm going to show you really quickly. If we find the margin of error, S is not 0.04. Let me try that again. 0.4, and N is 75. And you do, in fact, get 0.092, so that's why that one's true. C says the margin of error would decrease if the sample size were changed to 125. So all you gotta do is now plug in the sample size of 125, and you get 0.07155, and the sample size, the margin of error definitely went down, which is why C is also true. Okay, so I want you to try these two. We've already done the first two, so never mind. Alright, let's look at number 3. I want you to try this one. See if you can do it. Pause the video and try it in 1, 2, 3. I'm sorry, I don't know why the margin of error didn't come through, but there it is for you. Okay, so stuff to pay attention to. Random sample of 100 drivers, so that's your N. Standard deviation up here, that's your S. And you are definitely trying to decrease the margin of error. Okay. So which one would decrease it? The answer is going to be increasing the sample size. So what I'm going to show you first is what it actually is with this sample size. And then we're just going to increase the sample size. So, sorry, that's square root. So now I'm going to do 200. So I'm going to type both of these in the calculator, and let's see if the margin of error actually decreases. Alright, so notice it went from 0.5 to 0.35, so yes, it did in fact decrease. So sorry about number 1 and 2 being things that we've already done. My bad, didn't catch that. So this is pretty easy. They're going to give you the formula for this. You just have to know how to plug it in and just look at it. And then anything about the studies, number 5 was kind of hard, but anything about the studies, it's just make sure it's random. If it says systematic, make sure it's a system. It's pretty easy. Let me know if you have any questions.